I'm going to show you another tree diagram. This kind of tree diagram, this kind of event doesn't have with or without replacement. So there's another kind of context where the item doesn't get reduced, or whether it matters whether is it with or without replacement, but rather, right, the context happen in two stages. So for example, in this question, on any school day, Jane goes to school by bus or father's car. Okay, and then the probability that she will take the bus is 2/3. And what happened when she take the bus? What are the chances that she will be late if she takes the bus? Or what is the chances that she will be late if she takes a father's car? Okay, so it's like two stages. The first stage is how she go to school. The second stage will be whether she will be late or not. So there are no physical item involved. So when there is no physical item, there's actually no reduction. It doesn't matter whether is it a replacement or not replacement. So the first thing she needs to decide is how is good. If I'm going to draw a tree diagram, the first thing I'm going to decide is how is she going to go school. So is she going to go school by bus, or is she going to school by car? And we are only given the probability that she will take a bus. The probability that she will take a bus is 2/3. That means that the probability that her dad will send her will be 1/3. So this is the first stage that she needs to decide. Is she taking a bus or is she taking a car? And then the second stage second stage involve whether she will be late or she will be not late. So this one is like late. And then this one is like not late. So the question says that if she takes the bus, she has a 3/4 chance of being late. That's quite a high chance. 3/4 chance of being late. If she take the bus, that means she got 1/4 chance of not being late. But if she takes her father's car, she also has a chance of being late. The chance is 2/5, slightly lower chance of being late. Okay, so not late, that will be 3/5. Okay, so what will be the eventual outcome? The outcome will be she take a bus and then she's late. She take a bus and she's not late. She take the car, she ends up late. She takes the car and she ends up not late. So that will be the outcome. And you check the probability. For the bus and late, it will be 2/3 times 3/4. The bus and not late will be 2/3 times 1/4. Car and late will be 1/3 times 2/5. Car and not late will be 1/3 times 3/5. So again, if you want to check whether your probability tree is correct, you add up all the outcome. You add up the probability of the outcome. If nothing goes wrong, you will get a 1. So that is a check whether your probability tree is correct or not. After that, we're going to use the tree to answer the question. For part 1, what is the probability that Jane will be late on a certain day? So you look at the outcome, which two outcomes have late as the final conclusion? So what situation will she be late? So there are two situations where she can be late. She can take a bus and end up late, or she takes a car and she also ends up being late. So we got to add up these two situations. So these two situations will be the chances that she will be late every day. So you punch calculator on this. So you got 19/30. That means, right, every day, right, this is her chance of being late. Okay, so the next one is a tricky question. What is the chance that she will not be late for 2 consecutive days? So first of all, given for part 1, we already found the chance that Jane is late. So what is the chance that Jane is not late? So you can use the total probability to minus the chance that is late. So what is the chance that she won't be late for 2 consecutive days? So think about this in this way. She is not late for 2 consecutive late days. So break down the situation. That means, right, she is not late on the first day, and she's also not late on the second day. So the word and will tell you to multiply the probability. So the probability of not late is 11 over 30. The next day, she also got the same chance of not being late. So that will be my final answer. So it boils down to the keyword. If it's an and event, you multiply the probability. If it's an or event, you add the probability. Okay, so this kind of probability, this kind of tree diagram doesn't matter whether is it with or without replacement, because there's no physical item involved. It's just the stages. So these are the 2 stages involved for this example.